Now, Bernie, did you complete all of the questions that were on the review?
I have to be honest, I did not.
Oh, okay. No, it's fine. I just wanted to make sure because I haven't either. Oh, great. Did we just go live? Oh, man. It's the first thing they'll hear say, man.
Okay.
So, first one, the 90% confidence interval. What would be the best interpretation of the confidence interval? It would be that we're 90% confident that the true mean of heart rate's between 45 and 105?
Yes,
Okay.
that's what I say. Also, according to what I understood, and he sent out an email on it
Uh-huh.
last week. Did you read that?
Yeah, and then if there was the weird wording one too, so either we're 90% confident that it's within this range, or I don't remember what the other one was. I just remember that it was really weird wording.
Okay.
Okay, so then 20 the University of Mississippi.
One,
Um, so
two,
they get
seven.
their 20 females and 15 males. They're randomly selected, and they create QQ plots and see that they're approximately normal. Are the requirements or confidence interval satisfied?
Um,
I think that this is yes because we looked at the distribution and we saw that it was normal.
that's what I would say. Also, is yes, because it's normal, not necessarily central limit theorem, because you don't really have that big of a group. But
Okay. And it's okay because I mean even if they are less than 30 people in their group, then it's still okay as long as it's normal, right? Just if it's over 30, then we know that it's normal.
right.
Okay. Just wanted to make sure that was one I was not sure about. And then of the four types of confidence intervals, which one is appropriate? I would say the last one.
Yeah, because they aren't dependent samples, because nothing about the guys will lead you to anything to know about the females that they use. So
Hmm.
yeah, I'd say the last one as well.
Okay.
Um, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of big customers is found to be $3,402.08, $4,142.75, which the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval.
Well, would it be if you increased your sample size? So that second one, you do the balance of 90 bank customers rather than 30?
Yeah, I'd agree with that as well, because 99% you're going to have a
A larger margin of error.
right. So you go up on your confidence interval, you're going to have a larger margin of error, and then um, also if you go down is not as good either. So yeah, going up to 90 would do that.
Okay.
Um,
Let's see. So calculating.
oh, this is going back to our math from before, isn't it?
Yeah, this is from lesson 10, I think.
Yeah.
And then we have to use the corresponding z-scores. And for 95%, that z-score is 1.96.
Yeah. Okay. One point 26 or 1.96. Thousand. Four.
Only 4 people play. 4 people. So, I'm the big. Sorry. I'm the little.
Let me see.
I'm the big.
Okay, I
And
got for the
Sorry.
root.
1 megablock.
Sorry, did you find
Yeah,
the
I'm
form?
still working on it. Give me just a second. I'm sorry.
No, no, you're good. Don't worry. Do you need the formula?
I've got the formula. It's just the computing
Okay.
part.
It's a bunny. I don't remember. I don't remember. How about the mega function? The mega format looks like the
Just a
format
second.
function, but that's not the affiliate. There's a
Hmm.
I'm getting a giant, and my mega person is a giant.
I don't know if it's my internet or my computer. Everything's just really slow tonight.
But for this, that,
My computer's great.
come here. Come here.
Okay. Okay, I got 998.040 and 1001.960, the first one.
Yep. I got the same thing. The next one we want to find the sample size so we can get a specific margin of error.
Okay, so this one I'm a little bit more confused on.
Okay.
What's I'm not thinking. I'm sorry.
No,
What's
it's
the
okay.
formula we would use here?
The formula is n is equal to the corresponding z-score multiplied by the standard deviation all over m,
Okay.
and then all of that is squared.
Where are we at?
Here, I can write it down and hold it up to the camera if that helps.
That might help. Mm,
Okay. Is that
okay.
backwards for you?
I see.
Does
Yeah.
that look like it's backwards on your screen?
No.
Oh.
So the margin of error equals the
Sorry, no, so
z-score.
this is the sample size, and that's equal to the corresponding z-score multiplied by the standard deviation over the margin of error, and then all of
Oh.
that is squared.
Oh, okay. So you've gone ahead and done that. Okay.
Yeah. They actually give that formula to us in the book, and when we went up through it in the section, I went through and did all of it, so it was just nice because they actually already had it.
Okay. So our standard deviation.
And our standard deviation this time, remember, is 0.001. It's not 2.
Okay, so what's our z-score?
Our z-score is 1.96 because we're using a 95% confidence interval.
I don't know what I'm thinking. I apologize. I am.
Don't worry about it. today's an off day for me too, so you're good.
Okay. Hmm. N equals 1.96. Um, okay. 38,416?
Yep, that's what I got.
Okay. Okay.
So I'm just looking ahead, and there's not a whole lot more calculation questions. I think most of them are all not calculation questions.
Okay. Mean area of the several thousand apartments in new development is advertised to be 1,250 square foot. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses, HO and HA for you are, well, you're going to have HOU equals 1,250 and HAU is less than 1,250. So the first one, right?
Yep. And then the next one, I'm not quite sure about, but it says this is a statistical test of hypotheses. We say that the data are statistically significant at the level of significance if
The p-value is less than alpha.
that's what I was thinking, because if that's the case, we reject the null.
Correct.
Okay. Okay, number 10. A group of statistics students wants to determine if some apartment buildings get better grades than students in other apartment buildings. They collect GPAs using an anonymous random sample, 15 from 4 different apartment buildings. The data from each apartment building is bell-shaped with no outliers, and the sample standard deviations are nearly equal. Can they use the ANOVA hypothesis test to answer their question? I think yes.
I would say yes too, because it sounds with the bell shape that you have a normal distribution, but
That's what I think.
which yes is it?
Huh?
Which yes is it though?
I think it's the first one, that it is enough data that It is enough that the data are bell-shaped with no outliers, because you have to look at them each individually, and the 60 GPAs doesn't matter because you're comparing each
Yeah.
in sections of 15.
Okay, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has...
I know it's one of the first two, type 1 or type 2.
I just need to...
I believe, I want to say that it's type 1, where you reject the null that's really true.
Yeah.
That's what it says in that summary.
Okay. Type 1?
Yeah.
Okay.
12, if the level
Okay,
of...
the significance level... Oh,
Go
the
ahead.
level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small. What happens to the probability of committing a type 2 error? By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yep. So the nicotine content in cigarettes of a certain brand is normally distributed with the mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content in cigarettes is 1.5, but the measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. The null mean is equal to 1.5, and the alternative is that the mean is greater than 1.5 at the 5% level of significance. Okay. 5% level of significance. Wow.
I have to say it's failed to reject HO.
How come?
Well, let me see. You don't have a formula for
I don't think
this.
so.
I'm sorry, I forgot my notebook that's got most of my sheets in it in the car. So
It's okay. I've seemed to have lost the paper that had. Oh no, I know where mine is. So I've just left mine elsewhere too. So we can find the t-score.
yeah,
But we would want to find the p-value, wouldn't we?
yeah, because that's what's gonna.
Well, hold on. Do we need the p-score, or can we use the z-score in this case? Because if we can use the z-score, then we can just use the normal probability applet, and we're good to go.
Okay.
Let me see. And the z-score formula is sample mean minus the population mean over the standard deviation over the square root of n.
X minus U over omega 3 O. So 1.53 minus 1.50 over 100. Right?
Standard deviation of, so it's going to be over 0.17.
Standard deviation. Sorry.
Yeah, divided by the square root of 100. So I got 1.764 or 765, I guess.
.1765.
I got 1.765.
Yeah, I got 1.7647 whatever.
Okay, yeah. And that, cool. Okay, now what's our alternative hypothesis is that the mean is greater than 1.5, which means that we would take the area to the right of the positive z-score, which gives us a p-value of 0.0388. So then, yes, we would fail to reject the null. No.
No. Because if our p-score is 0.0388,
Right. It's less than our level of significance.
So we are going to reject the null.
Reject HO. Interesting. Okay, cool. Those nicotine addicts will get their nicotine. Okay, you like to look for the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 from each group and test if those means are different. What is the correct statistical procedure?
Independent samples.
Uh-huh. An educator is interested in academic achievement by males and females with similar academic support system. She decides to use brothers and sisters raised in the same home. Further, she decides that only brother-sister pairs, when they're next to each other in sibling order, should she use a hypothesis test based on independent or dependent? Well, it would be dependent.
If you select a brother so as to compare his academic achievement to a sister, you must include the sister in your study, right?
What? Yeah.
Okay. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file dissolved organic carbon. Use the information to answer 16 and 17.
Why didn't you tell us to open this before?
Oh, I hope I don't have a lot more to open because my computer is going so slow. Yep, we got a couple more data files to open.
Oh man. I hope that they actually give us a list of what. Oh no.
It's nice to have it open and ready before they. Okay.
Yeah. So you're gonna have to give me a second. Sometimes when I try to download the files, it just opens up a new tab with a bunch of gibberish on it. And that's what it did this time. So I need to go to a different browser and get it.
Perfectly fine. I still have to try to take over a school computer for a second, so.
That's a funny way to put it. I can just imagine some freshman that's just working on the library computer because his laptop died, and then all of a sudden SPSS starts up. He's like,
Yes.
what is this? Huh.
Yeah, looks like we got quite a few things we've got to download.
Okay.
Okay, but we could answer 16 right now, can't we?
I haven't looked at 16 yet. So the 4 types of confidence intervals, which one's appropriate? It would be the second one, a confidence interval for mu where sigma is unknown.
Mm-hmm.
Okay.
Oh, come on.
Used Hummers. I'll just download all of them right now.
Oh, I wish I could even get into mine.
Well, if worse comes to worse, we can always just screen share.
I think after we get done here, I'm going to reboot and see what's going on with my computer. It's been going slow all day.
Do you have a lot of stuff open?
No, I don't really.
Huh.
I thought earlier it might have been just because my wife was online as well doing her stuff. But
Is your wife doing online stuff or online school too?
she's doing the pathways right now.
Oh, okay, cool.
Oh yay! I got in. Yeah,
Did she like the pathway program?
Yeah, she does. I did pathways before I came back to school too.
Uh-huh.
We both attended school a long time ago. Not that long ago, but we both went there when it was still Rick's College. Does that give you an idea?
That gives me an idea. Yeah. The office that I work for at campus used to kind of be in charge of the pathway program. So when I first started working there, my job was to call people and let them know that they were eligible for pathways. So that was fun.
Slowly but surely, we will get there. The last time I went to school there, they still had a football team. How about that?
Ah, man, I miss having a football team. I really do. I remember going to football games with my older brother. Actually, I don't think I actually went with my older brother. I think it was just with my dad.
I actually
remember.
worked. I actually worked for the football team.
Oh, cool. I just remember that one of the football games we went to, they were playing the Artichokes. And I was like,
Yes, we always made
who
fun of them.
who would have the mascot of Artichokes? But
Uh,
it was
that
before I knew
was
what an artichoke was, though. So
no.
no.
There we go. I got a fatal error.
Yeah, I got that too.
Okay, so we need dissolved organic carbon. Come on. Okay. Okay. So, okay, so did you get 11.168 and 15.217?
Yes, I did. That means either we both got it right or we're both doing it wrong.
Okay. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Okay.
So we're gonna get the used Hummer data file now.
Yep. Okay. Okay.
I will tell you, I feel like it's a crazy data file.
Yeah.
I feel like this is how I should do my
Because
car shopping. Let's see. 120,000. Okay. It's black and it's in Los Angeles. Okay. Totally afford that. That's just pocket change. Kidding, I wish.
let me see. Okay. Okay. So I guess I'm confused. How would we do this? Because it doesn't tell us which ones are LA and which ones are New York.
It does. It's over to the right farther.
Oh, there we go.
Yeah, so I just recoded that so it had to groups 1 and 2.
Yeah. Yeah, I was just like, where? Okay. Code. Okay. Okay. Test variable is price. Grouping variables is city code. Group 1 is 1. Group 2 is 2. And now, come on. Okay. Okay. So.
I think we used that the bottom field, if I remember right.
Uh, 420. Yeah. It's either the top or the bottom. I think he said we always use equal variance is not assumed, right?
I think so.
Okay.
That's what I remember. Because I think
That's
last time we watched the video and had to find that. So
that's the way I remember it too. So I'm hoping we're okay.
hopefully that's right.
Okay. So let's go. Okay. So exercise bone density is the next one.
Yeah.
Okay, many studies have suggested there's a link between exercise and healthy bones. Exercise stresses the bones and this causes them to grow stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups. Control with no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, how do you make a rat jump 60 centimeters then?
You can train them.
Oh,
The rats that we're using in one of our experiments were used by the psychology department, and they were trained to jump, and they can jump.
hmm. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats, expressed in mg per centimeters cubed, was measured. The rats were selected at random for the 3 groups. Researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Okay. So what is the correct hypothesis test for this situation?
I would say ANOVA.
Yeah, I would too.
Okay.
Um, hmm.
Is that a good hmm?
So what'd you get for your test statistic on that?
I got 7.978. Because in this case, it would be the F score, right?
Yes, and I think I did it wrong. Um,
How did you do it?
there we go. I goofed. Okay, 7.978 is correct.
Okay. And then for the p-value was 0.002.
Yes.
Okay. And so 23, which of the following best expresses? I think that it's the second one, that there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density from one of the other groups.
That's what I'd say as well.
Okay.
Um,
So the next data file is direct flight costs.
no, great movie. Okay, direct flight costs.
So basically, the summary of the problem is that there's a study to determine if there's a difference between the mean cost of an airline purchased 90 days in advance versus that purchased 14 days in advance. Data was collected from the Heathrow Airport.
Okay.
Perform a hypothesis test to determine if there's a difference in cost of nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 0.10.
Okay. So we're going to use a dependent samples test, correct?
I think so. Yeah, because whatever we, whichever one we choose for the 14 days is going to determine which one, or I guess 90 days is what's going to determine what we use for the 14 days.
Okay.
Or the other way around.
14. Oh, come on. 14.
Okay, so
You do 14 minus 90, right?
good question. I think so, yeah. That would give us a t-score. And the t-score I got was 1.685.
Okay, just a second. Yes, 1.685.
Okay.
And the p-value is 0.096.
Mm-hmm.
So,
We would reject the null.
yeah, so there is sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days in advance, correct?
Mm-hmm.
Okay.
I think you've done good. I'm submitting it.
See how good we done.
100%?
Sweet.
Can we just take that score? Yeah.
For the test, that would be nice.
All right. Well, sweet. Good luck on the test, Bernie.
Let me see if I can. You too. We'll talk to you next time.